new case, and the last case in our series of cases related to game played by two or more players. The case is A, B and C toss a coin alternatively in succession. The winner is one who gets the head first. If A starts the game, find the respective probabilities of the three players winning the game. The game is to toss a coin. Definition of success is to get head first. In a coin, probability of getting head is 1 by 2 and failure of getting tail is also 1 by 2. There are three players, 3x, that is the sign of number of players in the formula. What exactly happens? We can visualize it like a movie. A starts the game, A wins, that's all. Or A fails and B wins. Or A fails and B fails and C wins. Or A fails and B fails and C fails and A wins. Or A fails and B fails and C fails and A fails and B wins. Or A fails and B fails and C fails and A fails and B fails and C wins in his second trial. Or and so on. The game can be continued indefinitely until one of three wins the game. So, considering OR as addition and AND as multiplication, this is a very simple case of summation of infinite geometric series. And in mathematics, we have many a times derived the formula of summation of infinite geometric series. We are going to use this as the formula to solve this problem. According to that logic, the probability of first player, in this case A, winning the game is S, probability of success, into 1 upon 1 minus f raised to x. Let us substitute the numbers or values. Yes, 1 by 2 into 1 upon 1 minus 1 upon 8. That means 1 by 2 into 1 upon 1 minus 1 minus 8. 1 by 8 will be 8 minus 1. 8 into 1, 7 minus 1, 7. 7 by 8. So it will be 1 by 2 into 8 by 7. So it will be 4 by 7. Probability of first player, in this case A, winning the game is 4 by 7. Now, in case of the second player, in case of, say, in this case B, what happens? A fails and now B is first turn. That means we can believe that B starts the fresh game. And considering B as the first player, the formula is same, but the reality is A failed. So ultimately the logic is A failed, that means failure, and B becomes the first player. So it is, or say, probability of second player winning the game is always, in this type of cases, probability of failure into probability of first player winning the game. So it is 1 by 2 into 4 by 7. So it is ultimately 2 by 7. Now the same logic is there. When will C's turn there? A fails and B fails and C's turn. So if A fails and B fails, now we can believe that C starts the new game. So C is the first player. A fails and B fails, and if we consider C as the first player, the logic is same. So in this kind of problems, probability of third player winning the game is always f square into probability of first player. And if we consider x number of players, the logic will be probability of nth player is failure, or rather f raised to n minus 1 into probability of first. Suppose we want to calculate the probability of fifth player in any other game or in any other problem. It will be f raised to 5 minus 1 into probability of first player. Nothing extraordinary is there. It is a simple logical extension of the probability of first player. Let us calculate it. probability of failure into probability of failure square is there. So it comes to 1 by 7. Probability of third player, that is C, 1 by 7. There are only 3 players, so exhaustive cases, and at a time only one player can win the game. So it is case of mutually exclusive events. So the summation of these 3 probability comes to 1. 7 by 7, 1. That's it. Thank you very much.